All right, number 17 says Noah wrote a number that the value of the thousands place is 10 times as great as the value of the digit to the right. So we want the thousands is 10 times the digit to the right. Okay, what could his number be? Well, does it really matter as long as you have the thousands is 10 times the digit to its right, which is your hundreds, right? If you do a place value chart, ones, tens, hundreds, thousands. That's the easiest way I know to prove this one to be correct. So we could do 5, 6, 7. So if we have 700s and multiply it by 10 times, you get 7,000. 7,000 is 10 times 700 because 700 times 10 is 7,000. And that's how you prove or show your work for number 17. All right, let's go to a new page. I'm going to make my 4 quadrants. We're going to work on number 18. Again, we're in topic 1 through 4 review. And this is number 18. Okay, so number 18 says Eleanor had 38 rolls of nickels. So we have 38 rolls of nickels. Each roll is worth $2. How many dollars in D does she have? Okay, so we would have 38 rolls times $2 equals D. Or we're going to do a tape diagram or a bar diagram. This is the total dollars, okay, with the variable D representing the total. And then here we need 2 38 times, right? Would be from here to there. Okay, so if I wanted to represent it with a tape diagram, I would have to write 2 in here 38 times, but that's a lot. So I just want to multiply 38 times 2. 2 times 8 is 16. 2 times 3 is 6, plus 1 is 7. So I would have to rewrite my problem, 38 times 2 equals D, $76 equals D. And that's how you represent that with your variable. So this is the A portion and this is the B portion. Because it said write an equation using the variable D. Okay, we did that. And then D equals how many dollars? Well, 76 equals D, or D equals $76. Any way you write it is fine. Doesn't matter. You're still representing what D is. All right, let's go to number 19. Yenzel and Allison made cakes for our house party. We have 18 berry, we have 6 chocolate, and 12 lemon. Each cake was cut into 12 equal slices. So we want to know times 12 slices. Excuse me. A is how many slices in all. So total slices. And B, we're going to use the inverse operation to check. All right, we're going to use the inverse operation to check. That we can do, no problem. So the first thing we have to do is we have to add all of those cakes together and then multiply them by 12. So our hidden problem would be this addition. And then the problem we know we have to do is multiply by 12, okay? Because we cut them all into equal parts. So let's do 18 plus 6 plus 12. 6 plus 2 is 8. 8 plus 8 is 16. 1, 2, 3. So we have a total of 36 cakes all together. And then we're going to do 36 times 12. It doesn't say which method to use, so I'm going to use the partial product method. We have 2 times 6 is 12. 2 times 30 is 60. I'm done with my 2. Then we have 10 times 6 and then 10 times 30. 10 times 6 and then 10 times 30. So 10 times 6 is also 60 and 10 times 30 is 300. 3 times 1 is 3. 10 times 10, 100. Add those together. We get 8, 12, 13. 3 plus 1 is 4. 438 slices. Now I need to do the inverse operation to check my addition. So I'm going to take this amount, 438, and subtract this amount to see if I get the right answer, okay? So I should get 36 slices if I subtract this right here from this, or excuse me, 36 total. So let's see. If we do 366 plus 60 plus 12, we're going to add all those partial products together, and we're going to get 8, 12, 13, 438. So that is correct. We did that, but now we have to subtract all of these out. I double checked my math because I wanted to make sure if I got it right. So remember, the inverse operation is the opposite. So we're going to work from the bottom up. So if we get 438 minus all of these, we should get down to 12. That would tell us that our math is correct. So we would write 438 first. Let's take out 300. We get 138. Let's then take out 66. 8 minus 6 is 2. We can't take 6 from 3, but we can say 13 minus 6, right? 7 plus 6 is 13. So 13 minus 6 is 7. That's 72. And then we'll subtract 60 from 72. And we get a total of 12. Our addition is correct. And it's okay that I went past my line, no big deal. If I need that box, then I'll just write the number down here instead of up there, okay? All right, let's do one more. Let's do number 20. All right. Number 20, Connor and Elliot volunteered to sell food to raise money for our class. They sold a lot. So the items they sold 312 popcorn bags, 195 candy bags, and 221 hot dogs. How much was sold? So the first thing we need to do, A is the total sold. Let's do that first. They have 312 popcorn, 195 candy, and 221 hot dogs. add that all together. 5, 6, 7, 8. Let me make this bigger for you so you can see it better. 5, 6, 7, 8, 9, 10, 11, 12, 3, 4, 5, 6, 7. 728 items were sold. All right, B. How many more bags of popcorn than candy was sold? So we're going to look at our chart. And we know that popcorn, there were 312 popcorn. There's 195 candy bags sold. The difference, how many more? That means we're subtracting to figure out the difference. We can't take 5 from 2, so we're going to cross out the 1 and make it a 0 and make that a 12. 7 plus 5 is 12. Let's make sure. 7, 8, 9, 10, 11, 12. We can't take 9 from 0, so we're going to borrow again. 10 tens from this 100. We'll borrow 100, make that 200. 10 tens, 10 minus 9 is 1. Then 200 minus 100 is 100. So the difference is 117 more bags of popcorn was sold. And then I'm going to circle that. Okay? All right, on to the next video.